In the last video, we looked at using the basic oscilloscope in Multisim, which looked like this. And now we are going to actually look at using a different oscilloscope in Multisim. So I'm going to stop the circuit. We're going to close this window and we're going to delete that oscilloscope. And now we're back to our basic circuit that's generating 120 volt RMS signal at 60 Hertz. And let's see, let's find the Tektronix Oscilloscope. It's the very last instrument right before the LabVIEW instrument there. So it's the last in the actual test equipment group. It's called Tektronix Oscilloscope. So I'm going to click that and I'm going to bring it over and put it in place. This oscilloscope it mimics or it simulates the actual Tektronix 2000 series oscilloscopes, I believe. And it's a 4-channel, has external trigger capabilities, which we're not going to get into right now. And but for our purposes, you just need to concentrate on the 4 inputs, 1, 2, 3, and 4. And we're just going to use one input right now. So I'm going to take input number 1 and hook it up to our circuit just like we did using the other oscilloscope. And then let's double click on it and it opens up the Tektronix Oscilloscope. Now we have some very similar to this that's actually in our classroom lab. They've been replaced with Regal oscilloscopes now, but we still have some of these. And I think we have the 50 megahertz models. This is a 200 megahertz oscilloscope, so it can measure up to about 200 megahertz signals, which we don't have to worry about measuring signals that high most of the time. But the good thing about this particular oscilloscope in Multisim is if you learn how to operate it, the real unit works the same way. So all the push buttons and the knobs and what you see on the screen they're all real simulations. So that's a good thing. All right, so let's see how this works. And so this is going to be similar. If you haven't seen the previous video on using the basic oscilloscope in Multisim, you need to watch that first and or skim through that one and get a refresher or get schooled on using the basic scope. Now we're going to move into using this more advanced oscilloscope that has a lot more features. But some of the things, the principles are the same. It doesn't matter what oscilloscope you're using. The principles will remain the same. This one just is going to give you more features. So let's look at it. First thing we need to do is run our circuit. And you'll notice that, oh boy, the oscilloscope is black. That's because you have not, or the screen is black. That's because you have not turned it on. So let's hit the power button. Now, notice that we have the same problem right now that we did in the previous video using the basic oscilloscope. It looks like our waveform is there, but it's way off the screen. So let's adjust it. To do that, I need to go to channel 1. So if you look here, you can see channel 1, 2, 3, and 4. So you have a volts per division control and a position control for each channel independently. And then also we have a horizontal control or horizontal section here that controls the horizontal settings of the oscilloscope. Very similar to what we had with the basic oscilloscope. We have some other things here that we did not have with the basic oscilloscope that we'll look at a couple of those in a moment. So we know that our waveform is too big. We're currently set to 1 volt per division for channel 1. Our horizontal setting is 2 milliseconds. So let's adjust the volts per division. And to do that, you just kind of click on this and drag the knob around with your mouse. And that looks pretty good. So you can see that we have a waveform. So I'm looking at a little bit over 1 cycle of the waveform here. And the trigger is currently up here at the top. You can tell that it is triggered. This particular oscilloscope gives you a indication when the waveform is triggered. And it's flickering and jumping around a lot here, but that's just because of the software, or it could just be my computer too. Let's hit stop. And let's hit start again. All right. Now the trigger, let's see, set to 0. That's, that's position. I'm sorry. There's a trigger menu. Here's the trigger section. So you can see right there, there's a section on the screen labeled trigger. And so we have trig view, force trig, set to 50%. And then we have a level control. And then we have a trig menu. So we can click that and actually get some more settings in the menu. Currently, the trig level is probably set to 0. And unlike the basic oscilloscope, this one trigs in the center of the screen. You see that little white arrow there? That shows you where the current trig marker is. And the trig level is probably this yellow arrow here on the left, I would think. Let's see. Let's actually move the trig level. Oh, it's on the right. I'm sorry. I ought to know a little bit more about this, hadn't I? So there's our trig marker on the right. See that? And don't forget, it's triggering in the center of the screen, not the left edge. So what happens if I click that? Nope, that wasn't good. So let's go back to in the middle at 0. Okay, so that's a little bit about the trigger. Measurements. Well, you can still use the old-fashioned way, I would call it, to make measurements. Currently, we're at 50 volts per division. So the center would be 0. Unless you have changed any settings that would affect that. Like if you change the vertical position, that would affect that. So you want to make sure that you haven't changed the vertical position. And if you haven't, then the center line would be 0 volts. So 50 volts per division. Let's count up from the center. That would be 50, 100, 150. So it's between 150 and 200, not quite halfway between 150 and 200. We already know what the voltage should be 169. So we're looking at about 169 volts there on the screen. So again, we can use the count the divisions method for calculating the voltage. We can also use cursors. This oscilloscope has cursors, and they're located here. There's a button called cursor, and you have to turn them on. So if I press that, that brings up my menu here. And it says currently the type of cursor is set to off. So you would change that. So do you want a voltage cursor? Do you want a time cursor? Or no cursors at all? Let's do a voltage cursor. So we want a voltage cursor. Now that we've done that, the source is going to be channel 1 because that's where we have our signal at. And now it says, there was something that popped up here. I don't know if you saw that. But also, these two lights came on underneath the position buttons for channels 1 and 2. These turn into controls for the cursors. So now we have a cursor. And so let's adjust. Look at there. There's a cursor that'll come up from the bottom. And this is cursor number 1. So let's get it up there to the top and get it sitting right at the peak, like so. Okay. Now let's find cursor number 2. Cursor number 2 was already up there at the top. So let's bring this one back down to the negative peak, like so. It's a little touchy. That's close enough. And let's put cursor number 2 right on that positive peak. Again, this is really touchy. like so. That's a little better. All right, that's close. So now it says that cursor number 2, I have cursor number 2 too high. It says it's at 171 volts. So it's not really touching the peak of that. That's a little better. All right, so cursor number 2 is at 168. Cursor number 1 is at negative 168. So, and then we get a delta. That means a change in, or the difference between the two cursors is 336. So that's pretty close. So that's how I can use the cursors to measure voltage. I can change the cursors to time. And now we can adjust the cursors. There's a cursor that pops up from the left. I can put it there. And then a cursor on the right. I can put it there. And we're close. It tells me what the time position is of the first cursor and the second cursor. But the big one is the delta, or the change, or the difference between the two cursors is normally what we're looking at. And notice it's 16.7 milliseconds. And look at there. This scope tells me what the frequency is, so I don't have to calculate it. So it does that automatically. 59.8 hertz. So pretty neat. I can hit the cursor button again. Nope, it won't go off. I got to actually turn those off. So there we go. So I just turned the cursors off to take them off the screen. So that's how we can measure. We can measure counting the divisions. We can also measure using cursors, just like we did with the basic scope. This scope has some additional tools for making measurements. You click the measure button, and now you're going to get 4 programmable measurements that you can do. Currently, they're all 4 set to channel 1. We only have a signal on channel 1. So we can click the first button, and it says, okay, what channel do you want to measure? Okay, we want to measure channel 1. What do you want to measure? Now we can click this. Every time we click this button, it'll change to a different measurement. You want to measure the frequency? All right, here's the frequency. Notice it's kind of jumping around a little bit, but you'll see it'll pop up with 0 there. Click this button again. You want to measure the period. 16.6, 16.7 pops up. Not sure why it's not stable. Let's see. Let me adjust the horizontal. Whoops. There we go. We get a better measurement there. Evidently there was not enough cycles on the screen for it to get a good sample to make the measurement. So the period is 16.6 milliseconds. Click it again. Mean, don't worry about that. Peak to peak. Peak to peak voltage, 338. Peak to peak voltage. Cycles RMS. This is actually our RMS voltage, which is 119 volts. And so, I mean, it should be about 120. Remember, our meter measured 119.999 or something like that. So we're getting 119 volts RMS. The minimum voltage is negative 169. Maximum voltage is 169. The rise time, 4.93 milliseconds. That's something we're going to talk about in another video. Fall time is also 4.93 milliseconds. And the positive width, in other words, the width of the positive section, 8.33 milliseconds. Width of the negative portion is 8.33 milliseconds, and then back to turn off for that one. So then we could go back and we could change another parameter. So let me show you how this would work. So let's go back to this first one. Channel 1, we want to measure the frequency, 60 hertz. Let's go back. See how that is stored, or that measurement is now assigned to that button, and it'll stay there on the screen as long as you stay in the measure mode. We can do the second button. We can measure something different, the period, and then go back. Let's go to peak voltage, and then go back. So now you can see the first three windows, or the first three settings, are measuring frequency, period, and peak to peak. And if this waveform changes, these values will change. So I don't have to come back here and actually measure every time now that I have it set up for that. It's very possible that once you turn the scope off and turn it back on, those could actually go back to none. But if I were to change this, let's do that. Let's change this to from 60 hertz to 50 hertz for European frequencies. I think it's European. And let's activate the circuit again. And now you can see that the frequency has changed to 50 hertz. The period has changed to 20 milliseconds. Peak to peak voltage is the same. That did not change, but the frequency did change. So that is an additional measurement tool that you have on this oscilloscope. You have some automatic measurements, which is really neat. You also have some menus, like we can go into the channel 1 menu. Currently the coupling is set to DC. It really doesn't matter if it's just a pure AC signal. But if it's a signal that has AC and DC, sometimes you'll need to use DC coupling to make certain measurements. You may need to make AC, or you may have to use AC coupling to make some measurements. So you have to keep that in mind. Like if you have, like if you're measuring ripple voltage on a power supply, hint, you have to actually zero in and get good measurements on just the ripple. You would have to change your coupling to AC. But to find out what the actual output DC voltage is of the power supply using the oscilloscope, you have to make sure you're in DC coupling so that it'll give you the DC value of the output waveform. So that's a situation where you got to be able to do both. You got to be able to switch back and forth depending on what you want to look at on the screen. Volts per division. Remember a while ago when I said it was really touchy? It's currently set to coarse. You can change that to fine, and it allow you to easily or more easily dial in your volts per division or your seconds per division on the controls. Invert, if you want to invert the waveform, that just simply flips the waveform. That really doesn't matter if you're just looking at one waveform. That's really handy when you're looking at more than one waveform, especially two waveforms that are kind of identical. You can actually, anyway, that's more advanced stuff. And we might get there. We might talk about that. So that's in the channel 1 menu. You also have a channel 2 menu, channel 3, channel 4, which is identical if for some reason you're using those channels to measure a signal. You have a math menu. This is only going to come into play when you're measuring more than one signal. So I hit that again, turn that off. So if you had like a channel A and you were measuring a waveform, or channel 1, and a channel 2 and you're measuring another waveform, you could actually add those waveforms together or combine them and look at the data from that. Or you could compare two waveforms using the math menu as well. So lots of uses for that. I think also in the math menu is where the FFT function is located. Yes, FFT. So you may see that mentioned before, or not before, but in a future lab or something. So that's in the math menu. One other thing that you can do, let's start the circuit back again. There is a run stop that basically freezes. So if we hit stop, notice that it says stop on the screen. That basically means that you have stopped and paused. It's like pausing the show on your television, if your television has that feature, where you can just basically freeze whatever's on the screen at that point. And this scope gives you that ability to do that as well. And sometimes that's very handy to do. There's a single sequence. Is that what that is? Single sequence. So you can tell it to acquire one complete screen and then stop. And so it'll fill the screen one time and then it'll stop. So that's handy. That's a little easier to use than the run stop button, I think, anyway. Well, there we go. I was hitting the wrong key on the keyboard. All right. And then finally, let's just say that everything on the screen is messed up and you don't know how to get a good waveform. This is a button you should not use, not on a regular basis anyway, because it really takes the work out of using the scope to the point that you'll never learn the scope and how to really zero in on frequency, or excuse me, on waveforms. And that's the auto set button. The auto set button actually tries to auto set the controls for you to get a ideal viewable waveform on the screen. It works 4 out of 5 times, depending on the waveform. So let's try it. Let's hit auto set. It takes it a little bit, and there it is. So it did a pretty good job of getting something usable on the screen. This may be not exactly what I want to see. Notice that we've got 8 or 10 cycles on the screen. Also, we can go up in volts per division just a tad like that. But we can fine tune like so. We can fine tune. You can also undo auto set. So if it didn't work, if it just really didn't help you much, there's an undo button where we can undo auto set, and it goes back to what we had before auto set. But not using auto set, you should be able to know that, hey, my volts per division are way too low because this waveform is off the screen. So let's bring our volts per division up, get the waveform in the bounds of the screen, and then let's adjust our horizontal seconds per division. So see, that didn't take much to dial that in. And now I've got a decent waveform on the screen. We saw a while ago, if you're planning to use measurements, that you got to have a few cycles on the screen for the oscilloscope to actually have enough of a view to do the math. So keep that in mind if you're not getting the measurements that you expect. Also, if any measurements have question marks beside them, that means that the oscilloscope is guessing at the measurement. It really doesn't know. It's just like if you see 16 milliseconds question mark, that means it's guessing. Also, don't take everything that an oscilloscope tells you as the gospel. If it says it's 16.6 milliseconds, sometimes these oscilloscopes, especially if it's a waveform that's other than a sine wave, sometimes these oscilloscopes can give erroneous data just depending on what type of signal you're looking at. So you have to have a little bit of smarts to say that, wait a minute, I don't think that what the oscilloscope is telling me is correct. It's like anything else. It doesn't matter what tool you're working with or what instrument you're using to measure. It still doesn't take away the human factor where you've still got to understand what you're doing. I've got an infrared thermometer that I can use to measure the temperature of different things. But if you don't really understand what that thermometer is and how it's working, it may give you a temperature reading that's not correct. And you just might assume that, well, everything you point that thermometer at, well, that's the temperature of it because that's what it says. Well, you might not be using it correctly, or you may have exceeded the limitations of the thermometer's capability because it just can't measure like a little pinpoint area 3 foot away. It's going to measure a certain size spot at 3 feet away. So anyway, it just goes to say that whatever instrument you're using or whatever tool you're using, you got to understand it. You got to understand what you're using the tool on to make sure that you're not getting erroneous data or you're not interpreting data improperly. Oh my, we got a lot of that going on in the world right now. Misinterpreting data. So make sure that like on an oscilloscope, if it gives you some sort of measurement, like in this case, it's giving me 60 hertz, 16.6 milliseconds. You need to know if that's in the ballpark. If not, make some adjustments. Move the waveform around. See, if I get this too small, that's as large as it'll go. So 100 volts per division is the max that this scope can do. But if we get some stuff on the screen like this, see that? So we don't have a proper waveform on the screen. It's telling me no frequency, no period, 145 volts peak to peak. Well, that's not correct. And you would have to know that. You need to know that the information is not correct. And so that means we need to get a better dial up here of our waveform, and then we'll get better data. So that's an introduction to the Tektronix Oscilloscope. Let's see. I've never used, not in Multisim, but on the real units. The real units have a USB port where you can plug in a flash drive and then you can save your waveforms on that. Let's see. Oh, that allows you to print. Okay, so I did hit the print button here. So it looks like it would allow me to print. Let me try. I have a PDF writer here. And print traces in color. Yes. So let's see if that works. I don't know that it will. It looks like it might. So it's going to name it scope-prn. I can rename that if I want to. It's going to put it on the desktop as a PDF file. So let's hit save. And so that very well may be saving a PDF file on my desktop. So we'll see if that happens. We'll look at that in just a second. Save, recall, save. That's where we can save it in memory usually. Stop, save, recall. I don't know if that's working here, on a real unit. That's like saves it in memory. You got a utility button. Let's see. So we can look at some things here. Trigger settings. So this kind of gives you a summary or the status of the horizontal section, vertical for channel 1 and 2, vertical for channels 3 and 4, trigger, and then miscellaneous. So then display, we can change our display to dots instead of vector format. Format YT, you can go to XY mode. That's something we talk about in the communications class. If you haven't had that class, that's coming up in the fall. But YT is voltage versus time, or the Y-axis versus time. You can increase or decrease contrast. And so this is very similar to the real oscilloscope, where you can go into these and make changes. The acquire menu tells you about how many samples it's going to do, and then back to the measure menu. There's also help, which that brings up the a help file here on the computer, but that would actually trigger a help screen on a real oscilloscope, where you could get some terms and definitions explained to you about the different things on the scope. Okay, well, so we have looked at the basic oscilloscope in the previous video. This video, we've looked at the Tektronix Oscilloscope. Let's turn the scope off. Goes to a black screen. Let's stop our circuit, because you can't modify the circuit really until you stop the circuit. There's another oscilloscope. I don't have much experience with it, to be honest. This is the Agilent scope. Double click it, and that's what it looks like. Just a different animal. It's still an oscilloscope made by a different company, but still simulates the real Agilent oscilloscope. So this one has a couple of channels accessible from the front panel. It also has a wiring harness where you can actually look at logic signals or digital signals coming from a logic circuit, for example. So that's why when you put it here, you've got lots of inputs here. That's probably 1 and 2. Channels 1 and 2, maybe. Let's turn it on. Hit the power button. Let's run our circuit. And see, we kind of got a similar thing that we had with the Tektronix scope. Adjusting channel 1. And let's see, here's my horizontal control. Like so. It gives you data on the screen, kind of lets you know what's going on. 50 volts per division vertical, and 10 milliseconds per division horizontal. And so again, it's just another oscilloscope. It shows you how different they can be as far as operating them, but they should all give, if it's done correctly, they will all give you the same result, whether it's a 50-year scope or a modern scope like these are. So that's the Agilent. And I think that's it, other than there's a 4-channel basic scope up here that looks like that. So works a little bit different. It's still in the basic scope category. I don't use this one that much. If I need 4 channels, I'm probably going to go to the Tektronix, but this one may be easier for some to use. I just haven't used it that much, just to be honest. So that's video number 2 on our oscilloscope, introduction to oscilloscopes and using the scopes. We're going to have some labs coming up where you're going to have to do some introductory measurements using the oscilloscope. And we've got a 3rd video coming for talking about measuring rise time on the waveform, and also going to do a little bit of review of capacitors in the process, show you a practical way of using oscilloscopes to measure time constants or charge and discharge time of an oscilloscope. So that's video number 3 coming right up. So if you got questions, let me know. So good luck.